Hey guys, so I just finished publishing a part 2 to the video on pulley size selection. It's basically just an air density calculator, how to build one in Excel. And then part 1 we talked about what the information is telling us and what its importance is for performance. I talked about this at the very tail end of the other video, but I wanted to make a separate video for those that were just interested in looking for a video about how to calculate density altitude. So this is just the simple calculation. It's just, unfortunately, the information out there is not very good. And so I wanted to just break it down, make it easy, and again, I'll show you where it's at in the air density calculator that we built in part 2 of the last video. But this is a simple calculation. So the first thing you're gonna do is calculate the pressure altitude. You can Google all these terms and if you really want to know what each thing is, but I'm just going to go how to calculate it, because at the end of the day, some of you only care about that. Normally I break it down and go over what each thing means, but for this video we're just going to keep it simple. First thing you're going to do is calculate pressure altitude, and all you need for this is atmospheric pressure. Again, don't worry about this sensor word. This is something I'm doing in C++ to program a sensor that will do this automatically for me. But the atmospheric pressure that you want here is not the atmospheric pressure you get on your digital weather device or the local news, because that's corrected to sea level and it's not accurate for your area. So you need the actual absolute air pressure. And like around here right now, it's really cold outside. So the air pressure today was 29.53 inches of mercury, and so that's 14.5 psi. You just need the inches of mercury. A lot of sensors will do this for you, but you'll need that pressure, not what the Weather Channel says. And then you need to know what your current elevation is. A lot of people, this is going to be the racetrack that you're at, or just where your house is at. If you're driving on the street, where do you spend most of your time driving? And this will be that current elevation. And then you're just going to do a simple calculation. This 29.92 is the sea level standard pressure. And that's what you're going to do a standard temperature in your density altitude calculation, and you got to get the standard pressure and standard temperature at sea level so that you can get an accurate density altitude. So you're going to do 29.92. This is a fixed value. It's always going to be that. That's what all your airfields are going to use for their density altitude calculations. And then all you're going to do is subtract whatever the atmospheric pressure is. So this will be 29.92 minus 29.53 for today. Okay, and then you're going to multiply that by 1,000. Okay, and then you're going to add your current elevation. Okay, so that'll give you your pressure altitude. Okay, so then you're going to calculate density altitude, and all this is you're going to take your pressure altitude that you calculated up here. Okay, and then that's going to be here. You're going to add, and this bracket just means you're going to perform these operations before you add here. Okay, so just order of operations, inside parentheses, then inside the brackets, and out here. Okay, so inside the parentheses, this is going to be your outside air temperature, and then your standard temperature for a given altitude. So all this is again another formula. So it's going to be 59 degrees. Okay, this is Fahrenheit, not Celsius. 59 degrees Fahrenheit minus, then brackets again. So the first thing you're going to do is elevation. This is your current elevation that you're at. That's this E up here, current elevation. Divide that by 1,000. Then you're going to multiply that by 3.5. This 3.5 is, you're losing 3.5 degrees from the standard temperature for every 1,000 feet. Okay, so you're basically just getting, if I'm at 715 feet, okay, You're going to take that 715 feet, divide that by 1,000. That's going to give you a percentage. Okay, and that percentage of 3.5 degrees is how much you're going to subtract from 59. All right, so that's the number. So that's your ISA, standard temperature for a given altitude. Okay, so you're going to do outside air temperature, which is just 25 degrees for me today, or at least this morning, and then subtract your calculated number from up here, your ISA. You're going to multiply that by 120. This is a fixed value. And then you're going to add that to your pressure altitude. Okay, and so the way this works in Excel, okay, if you just want to see how to do it in Excel, you have your current elevation. Anything in my spreadsheets that I do that's green is a number that you input. So there's no formula being done. It's just 715. Okay. So then the next thing is the same formula we just did for pressure altitude. So the way that looks is your 29.92, okay, minus your right here, your AP, which is your atmospheric pressure, okay, and then you're gonna multiply that by 1,000, and then add back your current elevation. Okay, simple formula. And then you're gonna come down here. This is the calculation I did here. This 59 minus 3.5 divided by, all it's doing is that formula, 59 minus parentheses, and then you're doing your outside air temperature divided, your elevation divided by 1,000, and then multiplying that by 3.5, and then subtracting that from 59. And then you go here, and that's your density altitude, and that's your formula here. Okay, so it's just your pressure altitude you calculated, inside parentheses, 120 times your outside air temperature minus your ISA that you calculated. And that's it. It's that simple, guys. So like this morning, it was negative 2,600 density altitude. Super good day for making power. My target for Old Red this Friday, I'm taking it to the dyno. Spoiler alert. And I'm hoping to get 500 horsepower. And on 9 pounds of boost, it looks like it might get close. On my 10 pound of boost pulley, if the air quality is anything like it was today, I should get it. So we shall see. We'll see what the density, air density is that day. I want to make a very specific comment here. Density altitude, while it is good, while it's good for a lot of things as far as just kind of comparing different tracks, it's really not a good indication of horsepower. So when I say that, the other calculator on the other video, we actually calculated density. Density altitude is not truly density. It gives you an idea, but it doesn't take into account humidity. And without humidity, you can't get your vapor pressure. And your vapor pressure, you can't get your partial pressure. And your partial pressure influences density quite significantly. So a standard day, they do that temperature and that pressure, but they do not. They do 0% humidity. So for density altitude, if you want to really do it correctly, you would add humidity into the equation. But for a draggy, an airport, all these little places that you guys get density altitude, they're not doing it for density. So if you want to do it like everybody else is doing it, just for a reference to kind of give you an idea, because it'll tell you a pretty good idea of how, if the air's better or not. It won't tell you how much better, but it'll tell you it's better. And then you can do my calculator if you want to know what the actual air density is that day, if you want to be real specific, especially for fueling and jetting in your carburetor, all that kind of stuff. So anyway, that is how you calculate density altitude. Have a good one.